In this video, we're going to look at using matrix mode on the Sharp EL-W516XG calculator to solve systems of equations. So first we must talk about what a matrix is. So a matrix is a set of numbers arranged in a rectangular pattern. The plural for a matrix is matrices. So if you have more than one matrix, you would have matrices. And matrices are used often to represent systems of equations. So for example, the system of equations 5x plus 7y equals -6 and -x plus 3y equals 2 would look like this in matrix form. So comparing the system of equations on the left to the matrix form on the right, you can see that that first matrix, that arrangement of numbers in a rectangular pattern of 5, 7, -1, and 3, lines up with the coefficients on our variables in our two equations. The 5 and the 7 are the coefficients on the x and the y in the first equation. The -1 and 3 are the coefficients on the x and y in the second equation. The second matrix, the xy, is our variables. The third, which is what we're equal to, is equal to the constants, so the -6 and the 2. Now, when we talk about matrices, because they are rectangular, we talk about the number of rows and the number of columns. So an m by n matrix has m rows and n columns. And if you've worked with spreadsheets before, just like with spreadsheets, rows are horizontal and columns are vertical. So for our first matrix, it's a 2 by 2 matrix because we have 2 rows and 2 columns. The second matrix, the xy, has 2 rows and just 1 column. Same with the -6, 2. It has 2 rows and 1 column. And a single column matrix is sometimes called a column vector. Now the Sharp EL-W516 calculator can handle up to a 4 by 4 matrix. That means it would have 4 rows and 4 columns. With that system of equations in matrix form, we call the first matrix, the 5, 7, -1, 3, the coefficient matrix, because it represents the coefficients from our variables in our equations. We have 1 row for every equation and 1 column for every variable. So we label that with an A, and when we're dealing with matrices, we bold the variable. So that's our matrix A. The second matrix, the xy, which represents our variables, is the column vector for the variables. It's a column vector because it has 1 row. So we label that as x. Again, that's bold. And those two are multiplying together to equal the column vector for our constants, so the -6 and 2, and again it's 1 column with 2 rows. So we say that this is A times X equals B. So the matrix A times the matrix X is equal to B. Now to solve for X, which is what we want to do because we want to find the value for X and Y, we multiply both sides of this equation by the inverse matrix of A, which is represented as a to the exponent -1. Now that's not the same as 1 divided by the matrix A. That's just the notation that we use to signify that it is the inverse matrix of A. Now we're not going to go into actually calculating out the inverse matrix of A. We will be using it, but we're going to be using the calculator to calculate it out for us. So we just need to trust that we need to multiply both sides of this equation by A inverse. So we multiply from the left on both sides. And when we do that, the A inverse times A ends up giving what's called the identity matrix. And when that multiplies by the matrix X, we end up with just X on the left side. And we have A inverse times B on the right side. So to find our values for X and Y, or all of our variables, we just take the inverse matrix of A and multiply by the column vector for our constants B. So let's take a look at an example of doing that using the calculator. For our example, we want to write the system of equations in matrix form, then use the matrix mode on the calculator to solve. And we're going to round our answers to 3 significant digits if necessary. So we have a system of 4 equations. with 4 unknowns. So because we have 4 equations, that means we're going to have 4 rows for our coefficient matrix, and we have 4 variables, which means we need to have 4 columns. So our coefficient matrix A is going to be a 4 by 4 matrix. So we start out by making our matrix for A. So we just go through recording the coefficients from each of the variables in our equations. So for the first equation, we have 1, then the coefficient on the y is -1, then the coefficient on the z is 1, then the coefficient on the w is 3. So I'm just going to close off that matrix there. And now we do the same thing for the second equation. So the coefficient on the x is 2, coefficient on the y is -4, coefficient on the z is -1, coefficient on the w is 1. Equation 3, coefficient on the x is -6. There is no y variable, so that means we have 0 y's, so the coefficient on the y is 0. We have a coefficient of 2 on z, so 2, and a coefficient of -5 on w. Then for our fourth equation, coefficient on x is 1, coefficient on y is 1, coefficient on z is -4, and coefficient on the w is 2. So that's our coefficient matrix A. And now that's multiplying our variable's column vector, x. So the variable's column vector is one vector with the number of rows equal to the number of variables. So this is going to be a 4 by 1 matrix. So we have our 4 variables in order, x, y, z, and w. And that's going to be equal to our constants column vector b, which is going to be 4 by 1 as well. It's one column and one row for every equation that we had. So we had 4 equations, so 4 rows. -8 was the first constant, -23 was the second, 22 was the third, -13 was the fourth. So this is our equation, or system of equations, in matrix form. So we have our coefficient matrix A, we have our column vector for the variables x, and that equals the column vector for our constants b. And now that we have the system of equations in matrix form, we need to enter this into the calculator. The first thing that we'll do when entering this into the calculator is to go into matrix mode. So to do that, hit Mode on the calculator and then 5. It doesn't appear as an option, but if you hit the down arrow, then you can see the 5 is there. So we're going to hit 5 for matrix mode. So now we can see that we're in matrix mode on the calculator. Next, we want to enter the coefficient matrix A. To do that, we start by hitting Math and then 1 for Edit. And now we see this matrix, and it currently has a 2 by 2 matrix, but matrix A is a 4 by 4 matrix. So we need to change that 2 by 2 to a 4 by 4 matrix. So we do that by hitting 4 for the number of rows. So now you can see the matrix has expanded to give us more rows. And if we hit 4 again, that will give us the number of columns. So now it's expanded in the number of columns. If we now hit equals, we'll go down into the matrix where we can start entering our values from the coefficient matrix A. So in our first row, we had 1, hit equals, -1, hit equals, 1, and then 3. And you can see how the screen moved over to show us that fourth column. When I hit equals, it's going to take me down to the second row in the first column. So now I'm back to entering the coefficient that was on the x in the second equation. So we have 2, -4, -1, and 1. And now when I hit equals, it's going to take me back to the third row to enter the information for the third equation. So the coefficient on the x in the third equation was -6. So we have -6. Then the y coefficient was 0, so I'm just going to hit 0. Just going to hit equals to move on to the next value. The coefficient on the z was 2, and the coefficient on the w was -5. Hit equals, and now we're down to the fourth row to enter the coefficients from the fourth equation. 1 for the coefficient on the x, 1 was the coefficient on the y, -4 was the coefficient on the z, and then 2 was the coefficient on the w. Make sure to hit equals on this last one to enter it in. And if you use the arrow buttons, you can move through to see all the values from your that you've entered for your matrix. And if you've made a mistake, you can just arrow to the one that you entered incorrectly and type it in again. Okay, so now that we've entered all of this in, we've entered in all the information from the coefficient matrix A, I'm going to hit the on clear button. So the ON/C, which is up at the top right of the calculator. Now it looks scary because everything's gone, but fortunately it hasn't erased anything. It's still there in the memory of the calculator. What we now want to do is store it as a matrix in the calculator. So we're going to hit math again, and then 3 for store. And now we want to store that as matrix A, so I'm going to hit 0 for matrix A. And you can see it came up and showed stored. That means matrix A is now stored in the calculator. Next, we want to enter matrix B. To enter the constants matrix B, the -8, -23, 22, -13, we start by hitting math, then 1 for edit. And you can see that we have the matrix that we just entered into the calculator still here. We want to replace that with matrix B. Matrix B is a 4x1 matrix. It has 4 rows, 1 column. So we're going to replace the 4x4 with 4x1. So just type in the 4 to keep the 4 for the number of rows, and then 1 for the number of columns. And you can see that the number of columns has just shrunk down to 1 column. Next, we hit equals to go into the matrix to start entering our values. So our first value was -8. Type in -8, hit equals, it goes down to the next row. -23 was our next value, hit equals. 22 was the third value. And then the last value was -13. Hit equals on that to make sure it's entered in. And again, you can use your arrow buttons to go back and forth to make sure that all your values were entered correctly. If it wasn't, you could just type in the value that you want and hit equals, and it would replace it. Now we want to store this into the calculator again. So we're going to hit the on/clear button, and we're going to hit math, and then 3 for store. And we want this stored as matrix B, so we're going to press 1 for matrix B. You can see that it said stored there briefly. That means matrix B is now stored in the calculator, so we can use it for further calculations. Now we're going to use the matrix A and matrix B that we've stored into the calculator to calculate out the values for X, Y, Z, and W. To calculate out the solution to our system of equations, the matrix X with the X, Y, Z, W, we now need to use those matrices that we just entered into the calculator, so we need to retrieve them. So we're going to press math, and then 0 for matrix, and then 0 again to get matrix A. So now we have matrix A there. We can do a calculation with that, and we want to take the inverse of that matrix and multiply it by matrix B. So to get the inverse of matrix A, hit second function, and then the x squared button, and you'll see above the x squared in orange, there's an x to the -1. So putting that there, now we have matrix A to the exponent -1, which isn't really to the exponent -1, but what this is telling the calculator is that we need the inverse of matrix A. So when we type that in, the calculator is going to calculate out the inverse of matrix A. Now we need to multiply that by matrix B. So press the multiplication button, and we need to get matrix B in there. So again, we hit math, and then matrix, and now we want matrix B, so we press 1 for matrix B, and you can see it's inserted it now. So now we have the inverse of matrix A times matrix B. To get our solution, all we need to do is hit equals now, and it will calculate it out. And we get a resultant matrix, which is a 4x1 matrix, 4 rows, 1 column, which is what our matrix X was, a 4-row, 1 column vector or column vector. So what we have is X, Y, Z, W is equal to this matrix. So we have -1, so that's the X value, 4, that's the Y value, 3, that's the Z value, and if we hit the down button, we get the W value of -2. So that gives us our solution for this system of equations. X equals -1, Y equals 4, Z equals 3, W equals -2.